Hi guys, welcome back to the channel. My name's Benny, and today we're going to be doing a sort of 101 on just the notes on the piano, but it's going to take us into a bit of a deep dive into the science of sound. We're also going to leave the lesson with an understanding of what an octave is. So let's ask this question to begin with, right? What even is sound? And actually we've had, as a species, as the human race, we've had quite a good understanding of what sound is for over 2,000 years, really. So Pythagoras, whose name you might be familiar from high school maths, was able to realise that by having string lengths in certain ratios, you could get kind of what you call consonant, so pleasant sounds. And this is one of the first known applications of kind of maths to music. Aristotle, who also is an ancient Greek philosopher, was able to understand that sound has to travel through what's called a medium, which means that sound doesn't just travel by itself; it's got to go through something. Most commonly, it would be air, but you could put your ear to the end of a piece of wood and knock on the end of the wood, and you would get a sound transmitted through that piece of wood as well. So sound can actually travel through anything. But it wasn't until a guy called Vitruvius, who was working around 1st century BC, that we sort of started to get, the Vitruvius is the earliest detailed account of sound as a wave, and Vitruvius used this to do quite interesting things. He was like a theatre designer, so he was like an architect for theatres, and he would like place these vases around the outside of the theatre, and they'd have a certain shape which was designed to like resonate with voices or with singing, so it gave the theatre a real kind of atmosphere, if you like. Moving on a bit to the sort of late 1600s, so moving on quite a lot, it wasn't until a guy called Thomas Boyle, who was able to create a vacuum, that we really understood it. We proved beyond doubt that sound has to travel through a medium. So I'll just show you the setup of the type of setup that Boyle would have used. So it looks something like this. So what the experiment that would have been done in terms of sound would be, you get something like that makes sound like an alarm clock, let's say. You put it inside of the jar, and you use the air pump to slowly pull the air out of the jar until it's what's called a vacuum, which means there's no air in there at all. And what you find when you do this is that the sound of the alarm clock just gets quieter and quieter and quieter until once the air is fully out of the jar, you can't hear anything at all. So this proves that sound actually needs something to travel through. So we by modern times we have quite a good understanding that sound is actually sort of the air just vibrating back and forth. And the next kind of big question to ask is what is pitch? Because we have this idea, this human idea of like the pitch of a sound or a note. So we have like low pitch stuff like and high pitch stuff like and it wasn't until Galileo, who's famous for proposing that the sun is actually at the centre of the solar system rather than the Earth, that we start to really establish carefully that the pitch of a sound actually corresponds to how fast this vibration is taking place. So just to recap that, sound is air vibrating, and pitch corresponds to how fast. So this is high pitch, this would be like low pitch. So that how fast something's vibrating is called frequency. And there's a whole load of physics around waves and frequency, but this is for musicians, this is what we need to understand, is that, I'll say it one more time, the pitch of a note corresponds to the frequency of the vibration of the air. Okay, so now we know that the pitch of a note corresponds to its frequency, so again, how fast the air is vibrating. The question is, though, how does this work on the piano? What's this got to do with the piano? So what we'll do is we'll start by finding a specific note on the piano. So I'm going to show you how to find D, and we'll go from there. So the easiest way to find D is to observe that on the piano there are these, every so often there are these two black notes, right? So these two. And between those two black notes is a white note, and that's D. So that's a good reference point for, you've got two black notes and then the one between them is D. So if you ever can't remember the names of the notes, look for the two black notes and the one between them is D. So this is D. And so D is vibrating at some kind of pitch, right? And then as we go to the right on the keyboard, we actually are increasing the pitch and hence the frequency of the note that we're hearing. So if we start with D, and naming the notes, we're just going to do the white keys today. All we do is go along the alphabet. So we've got D, E, F, G, A, B, C. And all that's happening as we go to the right on the keyboard is that the pitch or the frequency of the notes is increasing. So just listen again and you can hear that it's getting higher and higher as we go to the right. So we've got D, E, F, G, A, B, C. And then something sort of special happens when we get back to this note, which is between the two black keys again. So this is D again, right? So D, E, F, G, A, B, C, D. Now the question is, how can we call these two things the same note, right? This and this, they have different frequencies, right? So they're different notes, but we give them the same letter. That's a bit of a strange thing in a way. And the answer to that question is that these are in an interval that we call an octave. So the distance between these two notes, that's an octave. Just a note on pronunciation as well. You hear a lot of people say octave, but the correct pronunciation is actually octave, if you want to sort of sound like you know the lingo. So this interval is an octave, and they have a special frequency relationship, these two notes. These two Ds, they're both called D, and the relationship frequency-wise is that this D, the higher D, has double the frequency of the lower D. So that means it's vibrating twice as fast. The air is vibrating twice as fast when I play this note versus this note. And that's what an octave is. It means that we've doubled the frequency of our note. So takeaways from today. To find D, look for your two black notes, these ones, and find the note between the two black notes, and that's D. And then you can just use the alphabet to go up. D, E, F, G, A, B, C. And then you're back to D again. This is an octave. And what we've done is we've doubled the frequency by going from here to here. So we will do a future lesson more on the science of sound, and for example, why does a D on the piano sound different to a D on a guitar or a saxophone? And we'll also cover more on intervals. So your most basic interval that we've covered today is called an octave, but there are lots of others. So yeah, thank you for watching. Please do like and subscribe. And if you have any questions, drop them in the comments. Or if you're interested in lessons with me, drop a comment and I will get in touch. Thank you for watching.